Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. Here you have information about online seminars that I teach for exams PFM, IFM, and LTAM, and about study manuals for exams PFM, IFM, and LTAM that I wrote. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. An insurance company sells two types of auto insurance policies, basic and deluxe. The time until the next basic policy claim is an exponential random variable with a mean 2 days. The time until the next deluxe policy claim is an independent exponential random variable with mean 3 days. What is the probability that the next claim will be a deluxe policy claim? And here's the solution. First, consider a general question like this. Two random variables, independent, both exponential, x with a hazard rate lambda x and y with a hazard rate lambda y. And we ask the question, what is the probability that one of them has a smaller value than the other, because exponential distribution corresponds to a waiting time until something happens. This is like asking, what is the probability that the event corresponding to x comes first? So x comes first. What is the probability of that? And because they're independent, we know that the joint density is the product of densities, so we can write this event probability as the double integral with values of x running from 0 to plus infinity, and then values of y, which are supposed to be bigger, running from x to plus infinity. So this is the integral from 0 to plus infinity of lambda x e to the minus lambda x times x, times the, and this with respect to x, of course, eventually the integral, times the integral from x to plus infinity of lambda y e to the minus lambda y times y dy. Okay, that first integral, the inside integral, not the first, but the one inside, is really the probability that y is greater than x. And of course we know that's the value of the survival function for y, so this is e to the minus lambda y times x. So the whole integral becomes the integral from 0 to plus infinity of lambda x times e to the minus lambda x times x, times e to the minus lambda y times x dx. Okay, well then we put that lambda x constant in front of everything, and it's the integral from 0 to plus infinity of e to the minus lambda x plus lambda y times x dx. That's actually exactly a bar angle infinity if lambda plus x were the force of interest, and a bar angle infinity at force of interest delta is equal to 1 over delta, so in this case 1 over lambda x plus lambda y. So this is, the final result is lambda x times lambda x plus lambda y. Now of course, if you haven't studied exam FM, so you may not be familiar with this a bar angle infinity, don't worry, just do the integral then. But one of the great benefits of studying FM is that you don't have to calculate some integrals because you memorize the annuity formulas. But that's okay. I don't insist that you have studied FM because you're studying for exam P. Although, reasonably speaking, everybody should take FM before P because it's an easier path to deal with it. In my humble opinion, you should take FM first. So anyway, in this exercise that we're doing here, let TB be the waiting time until next basic policy claim, and TD be the waiting time till next deluxe policy claim. The hazard rate of TB is 1/2, the reciprocal of its mean, and the hazard rate of TD is 1/3, the reciprocal of its mean. And the probability that TD is less than TB is, well, the hazard rate of the one that is smaller, so the one that's supposed to come second, the one that is supposed to come first, the smaller one. That's like x was less than y, and lambda x was at the top. So TD is less than TB, so the hazard rate of TD goes to the top. So it's 1/3 plus, divided by 1/2 plus 1/3. I multiply the top and bottom by 6, and this becomes 2 over 3 plus 2. So 2 over 5, or 0.4, which is answer C. Please remember this is copyrighted material. The problem itself comes from a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.